Hello, my name is Douglas Norberg, and I believe that the principle of relativity is uniform. It is a law of nature. The principle has been known since Galileo. The principle of relativity holds that the laws of physics act the same in any inertial system, moving or stationary. Everyone has experienced this. When you're on a moving plane or ship, nothing changes. You can move about just as you would in your own house. The laws of physics are unaffected by smooth, non-circular motion. An example of a person is a person throwing a ball at 40 miles an hour perpendicular to the direction of travel. From the perspective of the person on the ground, the ball vectors at an angle of 45 degrees. From the perspective of the person on the train, the ball travels straight ahead. Once again, only the person outside the inertial system sees any change. Modern physics holds that light is an exception to the principle of relativity. According to modern physics, the speed of light is absolute. It does not pick up the speed of the object it is propagated from. Light knows where stationary is. Why light would know where stationary is, I have no idea. I call this non-cumulative speed. The belief that light is non-cumulative is called the Einstein Synchronization Convention. It is derived from the fact that when Albert Einstein wrote his paper on the special theory of relativity, he stated this as his assumption. The Einstein Synchronization Convention does not result from an experiment. It is a mere assumption. The experiment that is supposed to prove the theory of relativity is the null result of the interferometer. In 1881 and again in 1887, Albert Michelson did an experiment with a device of his own design, the interferometer. He used a half-silvered mirror to split a light beam in perpendicular directions. The two beams travel equal distances and are reflected back by mirrors. Since the device is moving with the Earth, if light speed is non-cumulative, the distance traveled in the direction that is parallel to Earth's motion would be farther than the perpendicular leg. The waves would not arrive simultaneously and result in wave interference. I'm now going to show you a simple diagram of the interferometer. This is what it would look like. You can see that there's two arms, equal distance. I shall now explain what wave interference is. Wave interference is what happens when the wakes of two speedboats meet. The wakes or waves alternately enhance and cancel each other. The same thing happens with light. This was first shown by the double slit experiment by English genius Thomas Young. He cut two slits in a piece of paper and shined a light through the slits in a darkened room. What happened was a series of light and dark lines. The light waves alternately enhanced and canceled themselves. Wave interference is what Michelson expected to find with the interferometer. Now I'm going to show you what an approximation of what wave interference actually looks like. As you can see, it's just a series of light and dark lines. What Michelson was looking to prove was the existence of the luminiferous ether. Waves on water travel through water and sound waves travel through air. How did light travel through the vacuum of space? Michelson found no wave interference, thus the experiment is called the null result of the interferometer. Albert Michelson was given a Nobel Prize for this experiment. After the null result, the theory of the luminous ether was abandoned. Physics now believes that light consists of massless particles called photons. There are currently two interferometers in the United States. They are in Livingston, Louisiana, and Hanford, Washington. They are called LIGO, L-I-G-O. It stands for Laser Interferometer Gravitational Observatory. Their purpose is to detect gravitational waves predicted by the theory of relativity. Their legs are 4,000 meters long, and the devices are extremely accurate. They have been successful in detecting gravitational waves. When the results of the null result of the interferometer were published, physicists were astounded. Then Hendrik Lorentz and George Fitzgerald proposed that the interferometer was compressing in the direction of motion. This is now referred to as the Lorentz-Fitzgerald contraction. When Albert Einstein came out with his theory in 1905, physics then had a theory to explain the null result of the interferometer. Not only did space contract, but time dilated. These up here are this is the null result of the interferometer, both for space and time, and this is a diagram of how it would work, because what you would actually see is very little thing happens until it gets very close to the speed of light. Personally, if there are two concepts that should be constant, it is space and time. That space and time are variable is something I have never been able to accept. It is worthy of note that Albert Michelson never accepted the theory of relativity. I think I am in good company. The theory of relativity only became accepted after all the existing physicists died. English professor Brian Cox said that the theory of relativity explains all results. That is, it would have no paradoxes. This is not true. If a person were on a rocket ship close to the speed of light, he would be as thin as a piece of paper. How a person could be as thin as a piece of paper and be alive is something I cannot imagine. Contradiction of space itself contradicts the principle of relativity. The weirdest paradox of the theory of relativity is the singularity. If a body in space has a small g of 299,792,458 meters per second, the speed of light, space itself cannot exist. This is the very definition of a paradox. A singularity would also be a black hole, and black holes do exist, but are they singularities? In addition, objects in space have been seen to be traveling faster than the speed of light. This is supposed to be an optical illusion, is it? Quantum entanglement is another paradox of the theory of relativity. If you have two electrons quantumly entangled, if one electron changes its spin, the second one does simultaneously. The mathematics of quantum entanglement say that quantum entanglement is instantaneous. In 2022, Elaine Aspect, John F. Clauser, and Anton Zeilinger individually won the Nobel Prize in Physics for doing experiments that prove that quantum entanglement does indeed occur across space. This means that the math of quantum entanglement is correct. Quantum entanglement travels instantaneously and violates the theory of relativity. According to the Lorentz-Fitzgerald contraction, nothing can travel faster than light. If an object traveled as fast as light, time would stop, the object would shrink to nothing, and its mass would be infinite. The theory of relativity is based upon the belief that light speed is non-cumulative. What if light speed is cumulative? If light speed takes up the speed of the propagating object, the null result is simple to explain. Both light beams would travel the length of the interferometer in the same time and arrive simultaneously. No wave interference would be seen, exactly what Michelson found. When I first had this idea that light speed might be cumulative, I couldn't explain the null result of the interferometer because I thought light bounced off a mirror. If so, the return speed would be at normal light speed. Light would not then arrive simultaneously from both legs of the interferometer. However, light doesn't bounce. What actually happens is light is absorbed by the mirror's electrons and is re-emitted. Re-emitted cumulative light would travel at the speed of light, less the speed of the propagating object. Formula would be c minus v. It would offset the velocity of the interferometer itself and arrive simultaneously with the perpendicular beam. I want to introduce to you what I call Norberg's razor. Norberg's razor holds that when you have two contradicting theories, one complex and one simple, the simple one is correct. But you ask, doesn't the Doppler effect prove that light speed is non-cumulative? No, it doesn't. I will use the usual example of a man standing at a railroad crossing when an approaching train blows its whistle as it crosses the crossing. The pitch of the whistle lowers instantly as the train passes the observer. The reason for this is that the frequency of the whistle is compressed by the speed of sound as the train approaches and is stretched by the speed of sound as the train departs. The frequency of the whistle is actually altered by the motion of the train. Now, let us reverse the thought experiment. I shall put the observer on the train and the whistle stationary at the crossing. The man on the train hears the stationary whistle faster as the train approaches and slower as the train departs. The observer still hears the Doppler effect, but the pitch has not been altered by the motion of the train. I have previously mentioned the two LIGOs at Livingston and Hanford. The reader should now be asking, won't these LIGOs prove that light speed is cumulative or not? Yes, they do, and yes, they have. Vectoring proves that light speed is cumulative. Vectoring is what happened when our hypothetical baseball player threw his baseball perpendicular to a train traveling at 40 miles an hour. From the perspective of outside the inertial system, stationary, non-cumulative light would travel straight ahead, while cumulative light would vector in the direction of motion. From the perspective of inside the inertial system in motion, cumulative light would travel straight ahead, while non-cumulative light speed would be seen to vector in the opposite direction of motion. Here is a diagram of what would happen. As you can see, if you were outside a moving train, and non-cumulative light would travel straight ahead, while light would travel in the direction of motion. And the reverse is just the same. If you're inside the moving train, then light would travel straight ahead, and if it were non-cumulative, it would appear to go in opposite the direction of motion. The LIGOs prove that light speed is cumulative. The speed of the Earth traveling against the cosmic microwave background is 368,000 meters per second. The LIGOs are 4,000 meters long. It is almost certain that the Earth is not traveling directly parallel to one of the legs of the interferometer, but the angle to the nearest leg cannot be more than 45 degrees in any of the three dimensions. Since the Earth is round and Livingston and Hanford are at different latitudes, the vertical dimension is accounted for. By trigonometry, at 45 degrees, the distance of the appearance of vectoring of a non-cumulative light would be 2.835 meters. If speed is non-cumulative, the laser beam will miss the mirror. It doesn't. Cumulative light speed would vector proportionate to its speed and direction and strike its mirror directly in the center. The speed that the solar system rotates through the Milky Way is 230,000 meters per second at 45 degrees. Non-cumulative light speed would appear to vector 1.77 meters and also would miss its mirror. The Earth rotates around the Sun yearly at 30,000 meters per second. At 45 degrees, the beam would vector 0.231 meters or 231 millimeters. Non-cumulative light speed would appear, therefore, to vacillate at least 462 millimeters from winter to summer. The Earth turns on its axis at 465.1 meters per second at the equator. Livingston is at 30 degrees 5021 degrees north latitude. At that latitude, the Earth would rotate at 400.735 meters per second. At 45 degrees, the beam would appear to vector 0.00308 meters or 3.08 millimeters. Thus, the laser beam would appear to vacillate 7.16 millimeters every 12 hours. Hanford is at north latitude 46.5939. At that latitude, the Earth would rotate at 399.66 meters per second. At 45 degrees, the beam would appear to vector 0.002458 meters or 2.45 millimeters. Thus, the laser beam would appear to vacillate 4.916 millimeters every 12 hours. This is about the distance of 5 millimeters. It's not very much, but it certainly is detectable by an extremely accurate machine such as an interferometer. Another proof that light speed is cumulative is that if light speed is non-cumulative, it should measure slower than it calculates. This is because the measuring device is moving with the Earth as it is measuring. This is the same principle upon which the interferometer is based. Light speed is easily calculated. It is simply wavelength times frequency. Since distance traveled is longer than distance measured, non-cumulative light speed should measure slower than calculated. Cumulative light speed, however, would pick up the speed of the measuring device, and calculated light speed would agree with measured light speed, exactly what the measurements show. The next question is, why haven't you subjected this idea to both Livingston and Hanford? The answer is, I have, twice. They ignored me both times. This is why I am making this video. They will have to show, if it proves popular, they won't be able to ignore me. They will have to show the world why such an elegant explanation of the null result of the interferometer as cumulative light speed isn't true. They will have to show the world why the principle of relativity isn't uniform. I have to admit that there is a lot of supporting evidence for the theory of relativity. I can offer alternate theories to explain most of them, but I don't have to. It is if a theory's assumption fails, the theory fails. You cannot build upon a false assumption. There have to be other reasons to explain the consistency. For instance, does gravity bend space, or does it just bend light? No matter how many phenomena are consistent with your theory, to argue from the conclusion back to the assumption is circular reasoning. Circular reasoning, also known as bootstrapping and begging the question, is pure sophism. In conclusion, the viewer will please note that I have only attacked the convention, a mere assumption. I relied on only three physics phenomena: the principle of relativity, vectoring, and reflection. The reason that the laws of physics do not appear to change during motion is that both moving objects and light vector. Since motion causes vectoring, vectoring will offset the effects of motion. Thus, vectors are not seen within the same inertial system. This would be obvious except for the extreme speed of light. It takes an interferometer to prove it. Not only does the principle of relativity explain the null result of the interferometer, if the principle of relativity has no exceptions, it is a law of physics. I am done with my paper. If you want to read the actual paper that I have written and see my calculations, my email address is cdougn44@gmail.com. I'll repeat that again, cdougn44@gmail.com. If you send me an email, I will email. If you send me an email, I will email that paper back to you so that you can read it for yourself. Thank you very much.